In this video, we are going to talk about 3 types of rational equation word problems. The first type of problem we're going to talk about is number 1, which is a number combination problem. So these are pretty similar to the problems we did in the quadratics unit, but now they're going to be rational equations instead of quadratic equations. So it says one positive integer is 5 more than the other. So just like when we did quadratics, I'm going to have my first number is x, and my second number is x plus 5. Now, I'm going to take the reciprocal of the larger number and subtract it from the reciprocal of the smaller. Okay, that's a lot of vocab. So remember, the reciprocal means you are putting 1 over that number, and I'm subtracting it from. So the bigger one's actually going to be second. So my bigger number would be x plus 5. So I'm going to do 1 over x minus 1 over x plus 5. So I'm subtracting the reciprocal of my larger number from the reciprocal of my smaller number. And this is going to equal 5 over 14. Now, I have a rational equation, just like we've been working on solving. So I have 2 approaches to this. I can get a common denominator all the way across, but I think the easier way would be to just get a common denominator on the left side. And I'm going to accomplish this by treating my denominator. So I'm going to multiply the left fraction by x plus 5 over x plus 5, and my right fraction by x. And what that'll get me is I will get x plus 5 over x minus x over x. Oh, shoot, I made a mistake. My denominator is not going to be x. It's going to be x times x plus 5, excuse me, and that's what this denominator is going to be. That was the whole point of getting the common denominator. So now that I have a common denominator on the left side, I can combine my numerators. So x plus 5 minus x is just going to be 5. So now I'm going to cross multiply. Because when I have a fraction equal to a fraction, I can cross multiply. So I'm going to move that up here. So I'm going to have 5x times x plus 5 equals 70. So now I'm going to multiply out the left side, and I'll get 5x squared plus 25x equals 70. This is a quadratic equation, so I'm going to subtract my 70 over to make it equal to 0. Now I'm going to factor this quadratic equation. So especially when we have big numbers, always check for a GCF first. So I have a GCF of 5, so I'm going to factor out the 5. Once I factor out the 5, this is actually pretty easy to factor. It's going to factor into x plus 7, x minus 2. So my 2 possible solutions are negative 7 and 2. Now remember, when we did these quadratic equations, we're always looking for pairs of numbers. So my first pair, and I'm going to have a second pair. So my first pair is negative 7 comma something, and my second pair is 2 comma something. Now I have to go back and use my formulas way over here on the left side. So my first number is negative 7. Well, negative 7 plus 5 is negative 2. So that's my first pair. If 2 is a number, that means the pair is the 7. So there are 2 pairs of answers that work for this problem. We have to make sure that we state both pairs of answers. The second type of word problem we're going to talk about is called a work problem, as in like you go to work. And it's because it's going to relate to doing a job or doing some sort of work. So in this problem, it says, Abby has a lawn care service. One day her friend Jamal is working with her. Normally it takes Abby 2 hours to mow and trim the lawn. When Jamal worked with her, it only took 1 hour and 20 minutes. How long will it take Jamal to complete the job by himself? Okay, so we're going to use rational equations to help with this. So in general, when I'm setting up a work problem, I'm going to put the alone time on the bottom of each person. I'm going to put the together time on top, and then it's always going to equal one complete job. So we're going to kind of use this now. So my first fraction is going to be my Abby fraction. So it says it took her 2 hours, but together it took 1 hour and 20 minutes. Okay, so I got a little problem here. I need to switch this all into minutes before I can go about, because I don't want to have hours and minutes. So 2 hours, that's going to be 120 minutes. 1 hour and 20 minutes is going to be 80 minutes. So those are the numbers I'm going to use instead of the hours. So Abby takes 120 minutes to do the job alone. Jamal, well, we don't know how long it would take him to do the job alone, but together they would do the job in 80 minutes. And this equals one full job. Now I have a rational equation that I need to solve. So similar to the problem above, I'm going to get a common denominator on the left side, and then I'm going to cross multiply. So I'm going to multiply this first fraction by x over x, and the second fraction by 120 over 120. But actually, rather than doing that, I just realized that this 80 over 120 could be reduced, so I could make my numbers a lot smaller. So let's reduce this fraction before I get a common denominator. So 80 over 120 would be 2 over 3. Wow, now their numbers are a lot smaller. So now instead of multiplying by x and 120, I can multiply by x and by 3. Now, if I completed the problem using the 120 to x, I'll still get the same answer. I'll just have some reducing to do at the end. So when I get my common denominator, I'm going to have 2x over 3x plus 240 over 3x equals 1, which means I'll have 2x plus 240 over 3x, and it's going to equal 1 over 1. And I rewrote it as 1 over 1, so now I can cross multiply. And when I cross multiply, I'm going to get 3x equals 2x plus 240. Now I have a linear equation, not a quadratic. So I'll get x equals 240, which means it will take Jamal 2 hours. Actually, I take that back. Not 2 hours. 4 hours. Man, it would take him a long time to do it by himself. 4 hours to complete this job by himself. So remember, work problems is together over alone plus together over alone equals one full job. The last type of problem we're going to talk about is called we're going to use this formula, distance equals rate times time. So for all of these distance equals rate times time problems, I feel that the easiest way to approach these is to actually make a table for distance equals rate times time. So I'm always going to make a table for these types of problems. I personally feel it makes it easier. So Mary went on a road trip. The first leg of her road trip, so we talk about first leg meaning like first part of her road trip, was 120 miles of traffic. Oh, that's the worst. When the traffic cleared, she was able to drive twice as fast for 300 miles. If the trip took her a total of 9 hours, how long was she stuck in traffic? All right, so I basically have two scenarios. I have when she's in traffic and when there's no traffic. So when she was in traffic, she went 120 miles at some rate and some time. I don't know those two. But I do know when there was no traffic, she traveled 300 miles and was able to go twice as fast as before. Now, here's where the 9 comes in. The 9 is the total amount of time it took. So that means between these two, it's 9 hours. So if the traffic part took t hours, that means the no traffic part took 9 minus t. So let me give an example to kind of help explain this. Let's say that she sat in traffic for 3 hours. Well, that means 9 minus 3, which she would have been in no traffic for 6 hours. So that's why we use that 9 minus t model. And we're going to use that a lot with these distance equals rate times time problems. Okay, so the point of this table is to help me set up two equations. So I'm basically going to have a system. So my first equation is going to be distance, which is 120, equals rate times time. My second equation is going to be the same thing, but now it's 300 equals 2r times 9 minus t. Don't forget the parentheses. All right, so now I have a system of equations. I have two equations and two variables. So I need to solve for one of my variables in order to do substitution, because elimination is really not an option here. So what I'm going to do is I'm actually going to solve this first equation, and I'm going to solve it for r. So r would equal, well, to get r alone, I would divide both sides by t. So r would equal 120 over t. Now I'm going to take that 120 over t and I'm going to substitute it in for r in my second equation. So I'm going to get 300 equals 2 times 120 over t times 9 minus t. Now, I need to simplify this. Well, the first thing I'm going to do is multiply this 2 times the 120. Remember, this 2 is really over 1. So 2 over 1 times 120 over t is going to give me 240 over t times 9 minus t. Now I'm going to distribute. So again, this is like 9 over 1 and t over 1. So 240 times 9 is actually 2,160 over t minus 240t over t. Well, that last part of the fraction is actually going to simplify. Because if I have 240t over t, these t's will simplify. So I'm left with just minus 240. Now I need to solve this, and I got t in the denominator. So first I'm going to get that term with t alone. So I'm going to add the 240. And so I'm going to have 540 equals 2,160 over t. Now to get t alone, I need to actually multiply both sides by t. And then I'm going to divide by 540. And so t will equal 4. And in this case, my units are hours. So let's go back to the question and see if I've answered it. It says, if the total trip took 9 hours, how long was she stuck in traffic? Well, t represented the amount of time she was stuck in traffic. So this would be my final answer. Let's talk about a few other scenarios though. What if it said time in no traffic? Well, then I'd have to plug 4 into my equation for time of no traffic, so I'd have to do 9 minus 4, so it would be 5 hours. What if it asked the rate she went while in traffic? Then I want to take that 4 and I would substitute it into this original equation, this 120 equals r times t. And I would get that my rate was 30 miles per hour. I could do the same thing if it asked for the rate in no traffic. I could plug 4 in for t here and then solve for the rate in no traffic. Or I know that my rate in traffic is half the rate, or the rate in no traffic is double. So my rate in no traffic would have been 60 miles per hour. So make sure that when we finish solving, we've actually answered the question that it's asking.